Okay, so determine the number of maximum intercepts and turning points of a function. I got you some notes over here. Turning points, degree minus 1, intercepts no more than a degree. So remember, the degree is your highest exponent. Our highest exponent is 10. So our turning points, we're going to have 10 minus 1, so we have 9 turning points. Okay, and our intercepts no more than 10. So our intercepts, we have to have less than 10. We can't have any more less than or equal to 10. So you can have 10 intercepts, but no more. Because well, you're gonna have 10 solutions, but some of those can be imaginary, like we saw up there in one of our other problems. Okay, so if we have this, our highest degree is 12. So if our degree is 12, our turning points is 11, and our intercepts, the most we can have is 12, sorry, our degree. Okay, so that's determining the number of intercepts and turning points. And then let's look at the last thing, drawing conclusions about polynomial functions for graphs. Okay, so what can we conclude about the degree, turning points, and intercepts? So if we're looking at this graph, we see that our turning points, we have 1, 2, 3 turning points. Okay, so look at the graph and see if you can see anything else is happening. Okay, so with the turning points, what do you know about the degree? We remember to find the turning point, we do degree minus 1. So to find the degree, we would do 3 plus 1. So the degree has to be at least 4. So we add 1 to that to find this. And we see that we have an intercept here and an intercept here. So our degree has to be greater than 2. We know that. But then because this is 3, then the turning point is 3, our degree has to at least be 4. So our x-intercepts, we have 2 x-intercepts where it crosses the x-axis. Now remember, there can be more solutions. That would be imaginary. And also need to conclude that the degree is even, because we can look at end behavior. They go in the same direction, so we know that our degree has to be even. Okay, so let's look at the next one. First, they're going in different directions. End behaviors, different directions, so we know that we have an odd degree. Okay, we know that we have 1, 2, 3 x-intercepts. That means we have to have at least a degree 3. And we have 1, 2 turning points. So all of this data suggests that our degree is 3, because we got 2 turning points. Turning points plus 1 is 3. We have 3 intercepts. Okay, so we have an odd degree, and it's at least 3. We have 1, 2 turning points. We have 1, 2, 3 x-intercepts. They're going in different directions. Oh, also, it looks like it might be flipped. If it's flipped, remember it's negative in front of the coefficient. We really can't tell that, but I think it's flipped. Okay, so let's look at it not on a graph. Okay, so if we're looking at it not on a graph, we're looking at it not on a graph, then we are going to see what we can determine. Okay, so remember, let's start off by finding our y-intercept. So our y-intercept, we put 0 in for x. So y-intercept means I have negative 4 times 0, 0 plus 3, 0 minus 4. Negative 4 times 0 is 0, and then 0 times 3 times negative 4 is just 0. So our y-intercept is 0, 0. Then we need to find our x-intercept. This is already factored, so we don't have to factor it. But remember, if it's not factored, we have to factor it. Okay, so we have negative 4x equals 0 to find our x-intercept. X plus 3 equals 0. x minus 4 equals 0, so x is 0 here, x is negative 3 here, and x is 4 here. So our x-intercepts, we have 0, 0, negative 3, 0, and 4, 0. Okay, if we multiply this out, looks like we have a degree 3. And if we have degree 3, we got 3 minus 1, so we have 2 turning points. End behavior, we can talk about end behavior. If it's degree 3, and our leading coefficient is negative, so we can relate it back to this graph. We can relate it back to this graph. So what we're going to have is, as x approaches negative infinity, f of x approaches positive infinity. As x approaches positive infinity, f of x approaches negative infinity.